In this video, we're going to be factoring using the sum or difference of cubes strategies. So here on the screen, you're going to see the two rules for both the sum of cubes and the difference of cubes factoring strategies. Now, hopefully you're noticing that these are similar to the difference of squares. The difference of squares was two squareds, a squared and b squared, with a subtraction in between. What you're also hopefully noticing here is that with cubes, we actually have a sum property and a difference property. So you'll notice here that the only difference is that a and b are cubed this time. One option has a plus sign and one option has a subtraction sign. Now, you'll have to notice and keep track of the slight differences in the results of a sum of cubes or a difference of cubes. So what I like to note is that this is the sum and this is the subtraction. The first parenthesis here where it says a plus b matches what the original property is. So if it's the sum of cubes, it's a plus b. If it's the difference of cubes, it's a minus b. Then this second part here, both a squared and b squared are positive. You'll notice that. B squared is positive, a squared is positive. A squared is positive, b squared is positive. The difference is in this middle term right here. So when we have the sum of cubes, this middle term is subtracted. When we have the difference of cubes, this middle term is added. So these are just things you'll need to have written down and learn to utilize, but they are nifty little strategies that help you to factor very, very quickly. Now, if we're going to use cubed values, we probably need to have a list of cubes just like we had a list of squareds. So we should know and have these written down in your notebook. 1 cubed is equal to 1. 2 cubed is equal to 8. That's 2 times 2 times 2. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. 6 cubed is equal to 216. 7 cubed is equal to 343. 8 cubed is equal to 512. 9 cubed is equal to 729. And 10 cubed is equal to 1,000. So I would have those handy so when you see those numbers, you can tell instantly if you have a sum of cubes or a difference of cubes situation. So let's start and let's see if we can identify a sum or difference of cube situation and then use the property to factor it further. So what I notice here is that 8x cubed, this 3 kind of tells me that this might be a situation where we have a cube or a difference or sum of cubes situation. Now, because I see the subtraction symbol here, I know that it's a difference of cubes and not a sum because difference means subtraction. So what I need to check and see is whether or not both of these terms are perfect cubes. So what I like to take a look at is I think, okay, is anything to the power of 3 equal to 8? And I know that 2 cubed is equal to 8 from my list on the previous slide. So I know that if I took 2 and x and cubed them, well, 2 cubed is 8 and x cubed is x to the third, I would end up with 8x to the third. Then from here, I check 27, and I know that 3 cubed is equal to 27. So 27 can be rewritten as 3 cubed. So because both 8x cubed and 27 can be rewritten as cubes, here I know that a is equal to 2x and b is equal to 3, and I have a difference of cubes situation. Now if I look back at the factored situation that I wrote in the previous page, I know that the difference of cubes says a cubed minus b cubed, which in this case is 2x cubed minus 3 cubed. That is going to equal a minus b. Remember that first parenthesis matches the difference part of this original parenthesis. Then we have both a squared and b squared being added here. And because this is the difference of cubes, we actually add in a times b in the middle here. So all I'm going to do is take my a value of 2x and my b value of 3 and substitute them into this factored form here. So if I follow that pattern, I have 2x is a minus b, which is 3. A squared, so 2 squared is 4, x squared is x squared, plus a times b, well 2 times 3 is 6, and then we have the x, plus b squared, so 3 squared, which is 9. So by using the difference of cubes, I was able to factor that further to be in factored form here. So let's take a look at this next example here. So if I look at this at first glance, I notice that 24 and 648 do not match any of my perfectly cubed values that I wrote down a couple of slides ago. However, what I also notice is that they do appear to have a lot in common, so I want to check for a greatest common factor to start off. And what I notice here is that 24, if I divide 24 by 3, that would result in 8, and 8 is a perfect cube. So what I'm going to do here is I'm going to divide this by 3 and check and see if 648 is also divisible by 3. And when I do so, I realize that 648 is divisible by 3, so 3 is a common factor that they have in common. Now from here, I also notice that they each contain at least 4 x's. So I can factor out 3x to the 4th. Now note here that 3 might not be the largest common factor that these two terms have in common, but I do know that 3 is going to get 24 to turn into an 8, and since that's a perfect cube, I'm hoping that that'll give me a sum or difference of cubes situation that I can factor further. So if I divide both of these by 3x to the 4th and factor that 3x to the 4th out in front, 24 divided by 3 is 8, x to the 7th over x to the 4th gives me x to the 3rd. And I have a plus sign in between. 648 divided by 3 turns into 216, and the x to the 4ths cancel there. Now what I notice here when I look at those perfect cubes that I have on my list is that 8x cubed, that can be rewritten as 2x all cubed, because 2 cubed is 8, and x to the 3rd power gives me x cubed. What I also notice is 216 can be rewritten as 6 cubed. Now since both of these terms are perfect cubes, I can utilize either the sum or difference of cube strategy here. And because this is a sum, I'm going to utilize the sum of cubes. Now remember previously that if you have a cubed plus b cubed, that's going to equal a plus b in parentheses times, this becomes a squared minus ab plus b squared. So I'm just going to substitute my values in there, and I end up with 2x plus 6. And then I have, 2 squared is 4, and then an x squared paired onto that. 2x times 6 is 12x, so I'm going to subtract 12x, plus 6 squared is 36. Now, I've factored this part right here by using the sum of cube strategy. However, I can't forget that I did factor out this 3x to the 4th to begin with, so I need to carry that down here to note, well, first I factored out the greatest common factor, and then I used the difference of cubes to factor this further into fully factored form.